OBS. A lot of people don't know that, but it is part of OBS. But they just call it Streamlabs, which is basically the same thing. Now, I'm in the process of designing something new, which I haven't modelled yet. I'll explain why. Because at the moment, it's going to cost me a lot of money, really, to buy a load more filament to model something brand new, and also it's there's also options still available. And I was rummaging around my stash of motors and stuff. I've got a lot of motors kicking about. They're actually up here. Look, I've got a bunch of motors up here, right? And I tested that one. I also tested that one. And these have got higher torque, right? And I also tested this one, and I was quite surprised actually, because these motors, you see, when I used to do hi-fi video repairs years ago, what we used to do is we used to often get cassette players and CD players, and we used to have issues where they had a lot of wow and flutter, and we'd often replace the motors with new motors, and the old motors ended up in a big drawer full of basically junk. They're tossed in there, but they're ideal for running other equipment, you know, doing other things, even though they're not very good for running audio equipment because they've got the wow and flutter issue. Alright, so I tested this motor, and it has a quiescent current, that is without a load on it, of only 13 milliamps. That is quite extraordinary, and it's got quite a lot more torque than the CD motors which I'm currently using, which are these little ones, right? So I've been using these little motors, right, on the generator, right? So what I'm actually going to do is we're going to do an experiment running the larger, which has got a higher torque, because you can see by the size of it, there's a big difference in the size. That's because this CD1 motor runs at higher speed. Well, ideally we don't need such a high speed. What we really want is some higher torque. So, and this uses less current than that one, believe it or not. Quite surprisingly, but it has a larger diameter armature inside, which obviously is why there's more torque, and it's got better magnets in it as well than that one, because these tend to have them rubbery spongy magnets which aren't very efficient, whereas this one, it's got the hard type magnets, it's the ceramic ones. So it's got, because of that, it's got a higher torque ratio. So what I'm doing right now is printing a new motor bracket on the 3D printer, which is going to take an hour and a half or hour and three quarters to print. So anyway, I thought, well, rather than rushing into designing this new thing, which I'm going to be doing probably in a few months, I don't know, probably a month, I don't know, I'm not rushing into it, because it's going to require me to use a lot more filament, plastic and everything else. So I haven't exhausted my options with this thing yet, you see, this one. So what I'm doing right now is I'm looking at the gear ratios on this, because I might have to print a different pulley for this motor as well, because I'm not sure if the little pulley that's currently on the little motor down here, I'm not sure if it's going to be adequate, or I could gear ratio onto the smaller pulley up here. I could do it that way and use that pulley, but on this, so we can gain a bit more speed, because remember, this is a high torque motor, but it doesn't have such a higher RPM, so it's probably going to run a bit slower than the other one. But what I'm interested in is lowering the input current when I'm driving the anti-drag generator, right? So I want to minimize the amount of input current we've got, because the less input current we're using means that we have a better chance of self-powering the unit. right? So that's what I'm thinking. And obviously my new coil, I'm happy with it. It produces the output current on the new coil. It's pretty good for low voltage equipment. But this motor does require about 11 volts, right? But it's using less current, so maybe that will give me what I need. So I'm hoping that we could, if this is going to be efficient enough, and if it doesn't draw too much current, maybe I can tap voltage from the output coils on the Antidrag generator through a rectification, full wave rectification, to charge a supercapacitor, and the supercapacitor can then power this motor. So I'm interested to know if they can do that. So that's an experiment I've not tried yet. So obviously I'll have to boost start it or kick start it, you know, with an external power source. And I'll be interested to find out if it can actually drive this motor, because this doesn't draw as much current. I did a test yesterday on my meter. I was running it without a load on it, and it was literally about 13 milliamps, which is virtually nothing really. But obviously when you put a load on it, the current goes up. So, but I was putting my finger on here to slow it down, and I was trying to slow it down, and I was holding the probes and everything, and I was able to get it up to 50 milliamps, right, without pushing on this shaft quite hard, and it was still spinning. So it's got a lot of torque on it, which is quite interesting. So I want to find out what this thing can do, but it doesn't have the high RPM. That's the thing. So that's where I am at the moment. Anyway, I thought I'd just give you the heads up on that. So we'll see where we are when I get this thing assembled. So I was going to fit it in the opposite slot, which is this end. There's another hole there because this motor's sort of plugged into a hole in the side. So I was going to mount the other motor over here into this fitting, and then I could just move the belt over from there to there and power it, and we'll see what happens. Oh, the other thing is this motor runs in the opposite direction. It prefers to run in anti-clockwise direction rather than clockwise, so it's counterclockwise, I think. So yeah, it might cause me some issues, but I can run it backwards, I suppose, which is clockwise, so we should be alright, because my segments on the anti-drag are designed to reduce the drag when it's running in a clockwise direction, not anti-clockwise or counterclockwise, whatever you want to call it. So anyway, yeah, that's it for now. Thanks for watching.